Okay, now I'm going to tell you a little secret. This is how you can always win 100% the quadratic equation game. The secret is the quadratic formula. The formula itself tells you how to find the solutions. It's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This gives the solution, or both solutions, if there are two, to the equation ax squared plus bx plus c is equal to 0. One thing I want to point out right away is that there's a certain value in a square root sign here. So interesting things can happen. Some people write this triangle thing as a capital letter delta in Greek, the Greek alphabet. And some people write that letter for the discriminant, which is the term under the square root sign. It's b squared minus 4ac. Now what happens if the discriminant is less than 0? Well, then you'll end up trying to take the square root of a negative number. What happens when you do that? Things explode, right? Well, if you know about imaginary numbers, you can actually work it out. But for all real numbers, the square root just doesn't exist if it's a negative number. So if this happens, then for real numbers, we say there are no solutions to the equation. And if you might wonder how that can happen, just think of an equation like x squared is equal to negative 1. Well, remember that every time I square a number, it's either going to be 0 or positive. It can never be a negative number if I'm squaring a real number. So that's why it makes sense for some quadratic equations to say there's no solutions. Another interesting case is when the discriminant is equal to 0, in which case there's exactly one solution. If the discriminant is positive, then there's a plus or minus sign in the quadratic formula, and what that means is I can make that sign a plus sign or a minus sign, and I'll get two different numbers if the discriminant is positive, but both of those numbers will be answers to the quadratic equation. Okay, now I'm ready to write out some steps that you can always use to solve a quadratic equation using the quadratic formula. First step, we want to sort of figure out what a, b, and c are. So we're going to collect the like terms, all on one side. By like terms, I mean, let's say there's an x squared on the left side and an x squared on the right side. Well, I can subtract some of the x squareds from one of those sides so that they disappear on that side and they're only on, say, the left side of the equation. Second step is basically a follow-up from the first step. Just combine the coefficients of the like terms. Once you finish combining the coefficients, you should get a formula that looks like ax squared plus bx plus c is equal to 0. Great. Now you know a, b, and c. Step 3, find the value of the discriminant. We want to see if b squared minus 4ac is less than 0. If yes, then no solutions. Step 4, let's say the discriminant is not negative, then just plug and chug. Plug the numbers a, b, and c into the quadratic formula. Okay, let's go review the earlier examples from the quadratic equation game and see how those steps work to solve those equations. Remember, the first one started as 3x squared is equal to 2 plus 2x squared. Okay, great. Let's check the discriminant. The discriminant is equal to b squared is 0 minus 4ac, which is going to be negative 8. So minus negative 8 is plus 8. So the discriminant here is actually 8. Okay, cool. That means there's two different solutions. Now let's plug it in. I get negative b is 0 plus or minus the square root of the discriminant. It's the square root of 8 divided by 2a, which is just 2. So that's the same thing as plus or minus the square root of 8 over 2. And I can simplify that a little more. Remember, 8 is 4 times 2. So this is the square root of 4 times 2 over 2. And in fact, that's going to be the square root of 4 times the square root of 2 divided by 2. Square root of 4 is just 2, so the 2's cancel. And the overall answer is going to be plus or minus the square root of 2. Oh, there's two answers. The first time I went through this equation, I only thought of the positive solution, positive square root of 2. So that means I would have lost the game because I didn't come up with all the answers. It's a good thing I used the quadratic formula. All right, example B was x squared minus x minus 1 is equal to 2 plus x. And we simplified that before to x squared minus 2x minus 3 is equal to 0. And remember, we used factoring to solve the equation. We said x is equal to either negative 1 or 3. Just to see what happens instead of factoring, what happens if we use the quadratic formula? Well, the discriminant is going to be b squared minus 4ac. There's a negative here, so it's going to be a plus 12. So that's 16. And the quadratic formula tells me it's going to be x is equal to negative b plus or minus the square root of the discriminant all over 2a. That's going to be 2 plus or minus 4 all over 2. So if I plug in a plus sign there, I'll get 6 over 2 is 3. If I plug in a negative sign, I'll have negative 2 divided by 2, negative 1. Same thing. That's a smiley face because it worked out. Good job. All right, now we're ready for example C. Remember, we couldn't solve that one before, so let's see what happens. Example C is, well, we divided by 2 already, so we got x squared minus 4x plus 5 is equal to 0. Let's check the value of the discriminant. Remember, that's b squared, 16, minus 4ac. In that case, that's going to be 20. We get negative 4. Oh my gosh, it's a negative value for the discriminant. What does that mean? No solutions. In capital letters, because that's why we couldn't factor it. Aha. All right, finally, let's take a look at example D, which, remember, was trying to find the golden ratio. The equation we got out of that was x squared minus x minus 1 is equal to 0. The discriminant is going to be 1 minus 4ac, which is negative 4. I'll put 1 plus 4, and I'll get 5. And I'm ready to use, this is positive, so we have two solutions. So I'm ready to use the entire quadratic equation. Negative b is 1, and plus or minus square root of the discriminant all over 2a, which is just 2. And in this case, it's not easy to simplify the square root because square root of 5 is irrational. There's not a simple answer for that. So I can write this as two different numbers. One is going to be 1 plus the square root of 5 over 2. And the other one is going to be 1 minus the square root of 5 over 2. Okay, great. Now we've solved the quadratic equation, but we didn't really solve the golden ratio problem. Remember, the golden ratio problem was to find the width of this rectangle, which had the property that if I put a square here, the smaller rectangle is the same shape. Okay, one thing we know about x is it has to be a little bigger than 1. Otherwise, it doesn't make any sense. If I look at this number here, well, square root of 5 is bigger than 2. So 1 minus the square root of 5, it has to be a negative number. So this solution is actually negative. In this solution, well, it's going to be two numbers that are positive added on top, so it's a positive number. So out of these two possible solutions, the only one that actually makes sense is this one. And it turns out this is the golden ratio. Good job.